Hello everyone, welcome back to our channel. So today we'll be solving these questions from exercise 2.1 of our polynomials chapter. We have altogether 5 types of question. So in our question number 1, we need to identify which of these are polynomials and which are not. And we will also give some reasons for why one of them is polynomial and the other one is not. In the second question, we just need to write the coefficient of x square of these questions. In the third question, we need to give one example of a binomial of degree 35 and monomial of degree 10. In fourth one, we just need to write the degree of these polynomials, and in the fifth one, we need to classify the given polynomials as linear, quadratic, or cubic. Okay, so let's start with our question number 1. So in our question number 1, we need to identify which of the following are polynomials in one variable. Okay, this is also important. They need to be polynomials in one variable and which are not, and we'll give reasons for our answer. So let's look at the first one. This first one is a polynomial. Yes, it is a polynomial. Now the question is why and how do I know this one is a polynomial? The way to check whether an algebraic expression is a polynomial or not is you check the power of these variables, okay, or these alphabets. And if the power of these variables are whole numbers, okay, if they are whole numbers, then they are polynomials. So whole numbers are numbers starting from 0. So we have 0, 1, 2 and all the integers, okay. So if we have the power of these variables as whole number, so in this case we have 2, and here when we have nothing we have 1, right? And in this case we know that the power of these variables are whole numbers, and that's the reason that this is a polynomial. And that's it, okay? That's all the thing we need to check to identify whether an algebraic expression is a polynomial or not. Now let's look at our second question. Here we have our variable as y, okay? The variables are alphabets A, B, C, D. So here we have our variable as y, and the power of this variable y is 2, which is a whole number. So this is also a polynomial. And you can write your reason as because the power of the variables are whole number, okay? So if the power is a whole number, then it's a polynomial, and that's just it, okay? Now in our third question, this is a little bit different, right? So here we have two variables, so the same variable at two places. So here the power of t is 1, so that's a whole number, that's fine. But here the power of t is not a whole number. Now let's see, okay? So we have square root of t, and when there is nothing here inside this radical sign, there is 2, okay, and the power of t is 1. Now when you remove this square root symbol or the radical symbol, what happens is we have our 1 already here, right? This one, this 2, when you remove that radical symbol, comes over here as divided by 2 in the power, okay? So we had square root t, which is actually t to the power 1 over 2, okay? So for example, if you had something like, let's say x square, and let's say we have something like cube root, then this is going to be, we have x square. When you remove this radical symbol, that 3 is going to be divided in the power, okay? So we are going to have something like 2 by 3. So here in our question number 3, what we have is the power of this t is 1 over 2, which is not a whole number, okay? So the power of this particular variable is not a whole number because it's 1 over 2, and that's not a whole number. And so this particular algebraic expression is not a polynomial, okay? No, it's not a polynomial. Why? Because the power of one of the variables is in fraction. It is not a whole number, and that's the reason it's not a polynomial, okay? To be a polynomial, the power of all the variables need to be whole numbers, okay? Now let's move to question number 4. So here again the power of this y is 1, which is a whole number, but the power of this y, okay, in our second term what we have is 2 over y, right? When you move this y in the numerator, what happens is the power 1 becomes minus 1, okay? The power becomes negative. And so again, this is not a whole number. Negative 1 is not a whole number. And so this is also not a polynomial. So what's happening here is, again, if you have something like, let's say 5 over a square, then when you move this a square in the numerator, what you are going to get is 5a to the power minus 2, okay? So when you move these numbers in the numerator, the power becomes negative, or the power changes the sign. Similarly, we had here y to the power 1. When it goes to the numerator, it becomes minus 1. The power plus 1 becomes minus 1. And as a result, we have a power which is not a whole number, okay? So our power is negative 1, which is not a whole number. And so this entire expression is not a polynomial. Okay, so that's our first question. Now let's look at our fifth question. In our fifth question, what we have is power 10, 3, and 50. All of these are whole numbers, so obviously this is a polynomial. But like I said before, the question is asking which of the following are polynomials in one variable, okay? We only can have one variable, but in our fifth question we have three variables. We have our x, we have our y, and we have our t. So though it is a polynomial, it is not a polynomial in one variable because there are three variables. So our answer for our fifth question is going to be no, it is not a polynomial in one variable because there are three variables, okay? So we have x, y, and t. We have three variables, so it is not a polynomial in one variable. So another way to look at it is, if you have variables in the upper part or in the numerator part, and if they have whole numbers as their powers, then they are polynomials. Otherwise, in other cases, if you have the variable inside square root like this, or in the denominator like this, okay, if that happens, then it is not a polynomial. You can have numbers inside the square root, okay? It's not necessary that the numbers need to be out of square root. You can have numbers anywhere. The thing that is important is the variables need to be in the numerator part, and they cannot have something like square root or cube root, and they cannot be in the denominator. They need to be in the numerator. They need to have a power, which is a whole number. If they satisfy only these two cases, then they are polynomials, okay? They just need to satisfy these two things. They need to be in the numerator, and their power needs to be whole number. And that's how we can identify whether an algebraic expression is a polynomial or not. And that's our first question. Now let's look at our second question, and this is pretty easy, okay? This is more easier than the first question. In our second question, we need to find the coefficient of x square, okay? So how do we find the coefficient of x square? It's pretty easy, okay? The coefficient of x square is the number just in front of the x square. So for example, if you had something like, let's say 2a plus b, then the coefficient of a is the number just in front of that a, which is 2. So the coefficient of a is 2. If someone had asked you what is the coefficient of b, then it would be the number just in front of b, which is nothing, right? There is nothing, so there will be 1 over here, okay? So when there is nothing, you can write it as 1 times b, and so the coefficient of b is going to be 1. And if we have something like, let's say 2a square, then the coefficient of a square is 2. It doesn't matter what you have in front or at back, okay? That's not important. The important thing is the number just in front of the thing that the question is asking. So if somebody asks you the coefficient of a square, then it is going to be 2. If someone asks you the coefficient of z, it's going to be 1. So here in our particular question, we need to find the coefficient of x square. So you just need to look the number in front of x square. So in our first case, there is nothing in front of x square. You can always put a 1 over here. 1 times x square is x square. So the number in front of our x square is 1, or you could say it's plus 1. So the coefficient of x square for our first question is just 1 or plus 1. In our second question, Again, we don't have anything in front of our x square, right? So you can just put it 1 here. And then the coefficient of x square in this case is -1, okay? The number in front of the x square is -1. In our third case, we have our x square over here, and the number in front of our x square is pi over 2, okay? Pi over 2 is a number, okay? So the value of pi is something like 3.14, and then we have divided by 2, that's a number. So the coefficient of x square in our third question is pi over 2. What about our fourth question? In our fourth question, we don't have an x square, okay? So we don't have an x square. Now, how do we find the coefficient of x square? So what we could do is I can add 0 times x square, okay, in our fourth question, or you can also write this multiply as dot, right? So 0 times x square. So 0 times x square is 0, and when you add 0 to this entire thing, it's going to be root 2x minus 1. So I can add 0x square. Now the coefficient of x square in our third question is going to be the number just in front of our x square, which is 0. So the coefficient here is 0. Or you could say, if you don't have x square, you just write the coefficient as 0, okay? You don't need to do this drama, you can just write it as 0. But you need to know, okay? You need to understand that, oh, it's because you can add 0 here, and that's why it's 0. And that's our second question. It's pretty easy, okay? You just find the number in front of this x square, okay, and you get your coefficient. Now let's move to our third question. So our third question is asking us to give an example of a binomial and a monomial of degree 35 and degree 10. So to give example of a binomial and monomial, we need to know what binomial and monomial are, and we also need to know what is degree, okay? So before doing this third question, let's do our fourth question first. So we would know what a degree is, and we will also learn what is a monomial and a binomial. So in our question number 4, we need to write the degree of each of these following polynomials. So we have 4 polynomials here, and we need to write the degree of these polynomials. Now, a degree of a polynomial is the highest power of the variable present in that polynomial. So for example, here in our first question, we have a polynomial, we have a variable x. And in our third term, we have power 1. In our second term, we have power 2. In our first term, we have power 3, okay? So the variables have power 1, 2, and 3. And the highest power is 3. The highest power is 3, right? It's pretty simple. Which is the highest one in 3, 2, and 1? It's 3. So the degree of this polynomial is 3. And that's it, okay? So the degree of a polynomial is the highest power of the variable present in that polynomial. Now, you can guess for the second question, the highest power in our second question is 2, because there is only one variable and the power is 2. So that's the highest one. So the degree of this second polynomial is 2. Similarly, in our third one, the highest power is going to be 1, because there is only one variable again. And so the degree of this polynomial is 1. In our fourth variable, again, we do not have a, in our fourth polynomial, again, we do not have a variable. And again, like I said, what you can do is, you can add a variable like this, okay, x to the power 0 in this fourth question. So 3 times x to the power 0 is going to be 3. You can add this, okay? So let's see. 3 times x to the power 0 is 3 times x to the power 0 is 1. Anything power 0 is 1. So 3 times 1 is 3. So you can write 3 as 3x to the power 0. And now we have our variable, and the highest power is 0. So the degree of this particular polynomial is 0. And done, okay? This is our fourth question. We just wrote the degree. Degree is just the highest power of variable present in a polynomial. Now we know what a degree is. For our third question, we also need to know what a monomial and a binomial is. Monomial is a polynomial with only one term, okay? So this fourth question is an example of our monomial, because there is only one term in our fourth question. In our third question, we have two terms, okay? So one term, two term. So this is a binomial. Again, our second question is also a binomial. So if you have two terms in a polynomial, then that's a binomial. If you have only one term, then that's a monomial. If you have three terms, you could call it a trinomial, right? So that's how it works. One term monomial, two terms binomial. Now, in our third question, we need to make a binomial of degree 35. So degree 35 means the highest power needs to be 35. So for a binomial, okay, let's do for the binomial first. For binomial, first of all, we need to have two terms. So let's say first term is 2x cube, okay, let's say it's cube. And then let's say our second term is x. Now we have two terms, that's a binomial. But the question is asking us to write an example of binomial of degree 35. The degree needs to be 35. The highest power needs to be 35. Here we have the highest power only 3. So this is wrong, right? We need the highest power to be 35. Now we can add power 35 over here with this x. Then this is a binomial and the highest power is 35. So it's a binomial of degree 35 and that's it, okay? It's not necessary that you add this 35 over here, okay? You could add this 35 over here. And again, this would be a binomial of degree 35 because again, we have two terms, so binomial and the highest power is 35. You can do it both ways. So that's our binomial. Now let's look at our monomial. So for monomial, we need to have only one term, right? So let's say our term is 5x. So we have one term, but the degree needs to be 10. So the power of this x needs to be 10. And so the highest power is 10, degree is 10, and it's a polynomial, it's a monomial because it has only one term. So it's a monomial of degree 10. And that's it, okay? It's pretty easy to give you an example of a binomial and a monomial. You can add any alphabets, you can add any numbers, okay? It's not necessary that you have to put 5 or x, okay? Another example could be, let's say you want to put 107 and you want the letter, let's say A, you like A, and then you could write the power as 10. So this is a monomial of degree 10. So the alphabets and the numbers, it's whatever you want to choose, but the degree needs to be 10, okay? It cannot change. And so we have a binomial and a monomial, and our third question is also complete. Now, let's go to our final question, which is our fifth question. And this question is also pretty easy, it's pretty simple. Now, let's see how we solve this. So we have to classify the given polynomials as linear, quadratic, or cubic. Now, what is a linear, quadratic, and cubic polynomials? A linear polynomial is a polynomial which has degree 1. If the degree of the polynomial is 1, then it's a linear. If the degree of the polynomial is 2, then that's a quadratic polynomial. Now for cubic, what do you think should the degree be? The degree of the cubic polynomial needs to be 3. So if you have a polynomial of degree 1, that's linear. If it's 2, then that's quadratic. And if it's 3, it's cubic. It's pretty simple. Now let's see what type of polynomials are given in our question. So we have our first question over here. The degree of this polynomial is 2 because the highest power is 2, right? This power is 1. Since the degree is 2, it's a quadratic polynomial. Our second question, you could guess this one. So the degree of this polynomial is 3, and so it's a cubic polynomial. For our third question, again, let's check the degree first. So the power here is 1, there is 2, highest power is 2, so degree is 2, so it's a quadratic. And for our fourth question, the highest power is 1 here, okay? Because there is only one variable and the power is also 1, and so it's a linear polynomial. It's a linear polynomial because the highest power or degree of this polynomial is 1. This fifth one is also a linear polynomial because the degree is again 1. Our sixth one is the degree is 2, so it's a quadratic polynomial. Our seventh one, the degree is 3, so it's a cubic polynomial. And done, that's it. Okay, that's how you classify the polynomials as linear, quadratic, or cubic. So what we did in this exercise is, first we learned how to identify polynomials. Polynomials are those algebraic expressions which have their power of the variables as whole numbers. And then we learned how to write the coefficient of x square or some variable. Okay, you just look at the number in front of the variable to find the coefficient. And in the third, we just learned how to give examples of binomials and monomials of any degree, okay, whichever you like. And then in the fourth, we learned about the degree of polynomials. What is the degree of polynomials? It's just the highest power of the variables. And in the fifth one, we learned how to classify the polynomials as linear, quadratic, or cubic. So if the degree is 1, it's linear. If it's 2, it's quadratic. And if it's 3, it's cubic. And that's it. So if you enjoyed our video and if you learned something new today, please give us a thumbs up and subscribe to our channel for future maths videos. Thank you.